Properties of bases. We know that bases are bitter in taste, but again there is a caution that please do not taste bases in the laboratory. They are so corrosive in nature. Bases are soapy and slippery to touch. And what base do with litmus solution is simply they'll turn red litmus to blue. And they also turn phenolphthalein solution into pink color and methyl orange solution into yellow. What basically base does is they actually dissociate, means break down into OH negative ions whenever we dissolve any base in water. So these are some basic properties of bases. Now let's have a look on the chemical properties of bases. The first one is reaction of bases with metals. So we know that metals are aluminum, zinc, sodium. These all are metals. So what base does is whenever a metal like zinc, aluminum, tin, lead react with strong alkalis. Alkalis are water soluble bases like NaOH, sodium hydroxide, potassium hydroxide, and what they will do is they will basically evolve hydrogen gas, means H2 is evolved. So whenever a metal is being reacted with a strong alkali or a strong water soluble base, we will get a salt along with the evolution of hydrogen gas. So let's have a look on the first example, which is ZnS, that is zinc solid. It is simply reacting with 2 moles of NaOH, and what we will get is are getting a salt which is sodium zincate, and again evolution of hydrogen gas. Similar for tin, so it will react with NaOH, we will get sodium stannite, which is a salt along with the evolution of hydrogen gas. Next is aluminum. Aluminum reacts with sodium hydroxide and we will get 2NaAlO2, which is sodium aluminate along with the evolution of hydrogen gas. So this is what exactly happens when a base reacts with metal. What exactly happening is salt is being formed along with the evolution of hydrogen gas. Now the topic is reaction of bases with non-metallic oxide. And basically non-metallic oxides are acidic in nature, means whenever they will react with a base, neutralization reaction will happen. That means acids and base will give us salt. So the example of non-metallic oxide is carbon dioxide, which is CO2, and sulfur dioxide, which is SO2. So they both are acidic in nature. So whenever an acid reacts with base, we will see a salt and the water. So here NaOH, which is a base, which is reacting with CO2 carbon dioxide, and we are getting Na2CO3, which is salt or sodium carbonate along with the water. Again calcium hydroxide, which is being reacted with SO2, which is sulfur dioxide, again acidic in nature, and we are getting calcium sulfite, which is a salt along with the water. So in general, we can generalize that base plus non-metallic oxide will give us salt plus water. Similarly for base plus metal, we can say that we are getting salt and hydrogen gas.